Welcome back. In the last video, I left you with the challenge of creating the function create EffNetB2 model, which reproduces all of these steps, but in a functional way, so that we could just call this function, and then we get our EffNetB2 transforms and our EffNetB2 returned. So let's do that now. I'm going to leave all this code here just so we can verify that what we're getting. I might comment this out so we save a little bit of space. So we can verify that if we do create a function, we're getting the same outputs as what we have above. So let's create a heading, creating a function to make an EffNetB2 feature extractor. Extractor. Wonderful. So let's start it off. Def create EffNetB2 model, and we're going to put in a couple of parameters here. You might have already done this in your own way, but this is just how I would do it. There's many different ways that you could do it. I'm going to set the seed to be 42. Number of classes will just be the number of output classes. I'm going to set that to by default to be 3 because we have 3 output classes. So default output classes equals 3, and this is for pizza, steak, and sushi. 1 for those. You can of course customize this to your own problems. Now, what are we going to do? Well, we want to go, let's do steps 1, 2, and 3 above in one hit. So create EffNetB2 pre-trained weights, transforms, and model. So we want, let's just do all the 3 steps in one hit, hey? Because we're getting pretty good at this. So the first one is weights, torchvision.model, and we'll get the weights. I keep typing EffNet for short, and that's there's a reason why I've given it a nickname. EffNetB2 weights, and we're going to get the default weights. Then we want the transforms equals weights.transforms. Then what else do we want? We want the model equals torchvision.models. Oh, and this should be models here. Models, and then we want efficient net. I have to sound it out. B2 weights equals weights. Wonderful. And then what's next? Well, we need to freeze all layers in the base model. So just like we did up here before, we set the requires grad parameter to false for param in model parameters. Now, this is a feature extractor model. My quiz to you is, what's the difference between a feature extractor model and a fine-tuned model? You can find the answer in, of course, transfer learning. Fine-tuning would, of course, be, we wouldn't freeze all the layers in the base model. We would tune some of them to our own custom data. Whereas feature extractor, you just leave the top layers trainable. So let's go. Number 5 is we want to change classifier head with random seed for as much reproducibility as we can get. Torch.manual seed. And then we want seed. Wonderful. Let's go model.classifier equals nn.sequential. Sequential. Have to sound that one out too. And from memory, this has a dropout layer with a probability of 0.3, and in place equals true. And then we have an output linear layer, which is going to have in features equal to 1048 or 1408, sorry. And then out features is going to be equal to our num classes parameter up here. So we could adjust that on the fly if we wanted to. Now, is that correct? Yes, that looks like it's lining up. Finally, we're going to return the model and the transforms. Now that's one good looking function, hey? Nice and simple. So if it all worked correctly, we should be able to create a model here, EffNetB2, which is going to be this, and then EffNetB2 transforms, which is going to be the transforms that our pre-trained model used to transform its input data that it originally trained on. And we're going to go create EffNetB2 model num classes equals 3, and then the seed we're going to set to 42. We don't need to set that because it's already by default. We will anyway, why not? Let's have a look at the transforms first, EffNetB2 transforms. Wonderful. So that means that every image that we pass through to our model is going to go through these transforms: crop size, resize, mean, and standard deviation. And then of course we can get a summary of our model. So this is this EffNetB2 here. We'll just go passing that instance here. Say we pass an image through of this size, 224, 224. We could also do 22 or 288, 288 if we wanted to. But there we go. We get exactly what we're after. So EfficientNet, all the base layers are frozen. They're not trainable, except the output layer is trainable, and it's customized to our own number of classes, 3. Trainable parameters 4227. So that's a pretty good looking function to me. So we've got a model ready now, and in fact we can recreate another instance of it quite quickly. We've got one here. What's next? Well, we've also got a data set. So how about we, in the next video, turn our data into data loaders? You might want to give that a shot. If you do, good luck. Otherwise, we'll do it together in the next video. I'll see you there.